In this video, we're going to review Pythagoras' theorem, and that is just a way that we can use some maths and some rules to find the side lengths of right-angled triangles. So here we have a right-angled triangle, and we know that it's right-angled because it has this symbol in the corner. And Pythagoras' theorem only works for right-angled triangles. So if it doesn't have one of these, we can't use Pythagoras' theorem in this way. Now, the way that we label our triangles is just with the letters A, B, and C, and we normally label our hypotenuse, which is the longest side length, and the one that is opposite the right angle, we normally label that one C, and then the other two are A and B, and it doesn't matter which one's which, really. As long as you label them and you use the correct corresponding numbers in your working out. Now, the formula for Pythagoras' theorem is a squared plus b squared equals c squared. That just means if I square this side length and that side length, it is going to be equal to that side length squared as well. Now, knowing this information, if we know two of them, we can find out the missing side length. Let's have a look at a couple of examples together. So here we have a right-angled triangle. We know it's right-angled. It has that special symbol in the corner. Two of the side lengths are labelled, and one of them isn't. So first, let's label these with letters so that we know which one's which. Now, the hypotenuse is usually, what's always, opposite the right angle, and it's also the longest side length. So this one is going to be C. The other two can be A and B, and it doesn't matter which one's which. So my next step now is to substitute the information that I do know into my formula and see if that can help us find the missing side length. So I know the side length A, that's 2 meters, so 2 squared, plus I know side length B, that's 1 meter, but I don't know C, so I'm going to leave that as the letter C. Now I can start to evaluate some of this. 2 squared is 4, 1 squared is 1, so that gives me 5, and we're not finished yet because we need to get C by itself. We're trying to find C, not C squared. So the way that I can get rid of that power of 2 is if I find the square root of both sides, what will happen is they will cancel each other out. So now I'm just left with C. And the missing side length is the square root of 5. So if you want your answer in exact form, you can leave it as that. However, if you're happy with the decimal, you can pop that into a calculator, and what you would get is 2.23607, and I want this one to 2 decimal places, which is these two here. So I need to look at the number that comes next, which is a 6. Now that's higher than 5, so that means that that 3 needs to be rounded up. So 2.24 is the answer rounded to 2 decimal places. So that's 2.24 meters. Here we have another right-angled triangle, and we know it's right-angled because it has the special symbol in the corner there to show that that's exactly 90 degrees. Now our first step is to label the sides. So we know that the hypotenuse is always opposite the right angle. It's the longest side, and that one has to be labelled C. The other two, it doesn't matter, but they need to be A and B. Now let's substitute those values into our formula and see if we can find the missing side length. So we know A, that's 1.1. We don't know B, so let's call it X for now. And we know C, that's 1.5. So this particular example here, our unknown side length is on the other side of the equal sign. So we'll take one extra step, but we'll be fine. Let's start to evaluate some of these things. So what we can do first is let's move 11.2 over to the other side. That would leave x almost by itself. So we would have x squared equals 1.5 squared. Now if I move this one over to do that, I need to go 1.1 squared. We'll have to minus that from both sides. So I would have minus 1.1 squared. So let's evaluate some of these ones. Let's find out what 1.5 squared is. So 1.5 squared is 2.25, and 1.1 squared is 1.21. So that would leave us with 1.04 equals x squared. Now x isn't on its own yet. We need to get rid of that square root. So those two will cancel each other out, and we also need to find the square root of this side. So the square root of 1.04 is 1.0198, and I want my answer to 2 decimal places, which is these two here. So that means that 1.0, now because the next number is higher than 5, this one's going to become a 2. So it's approximately, because we've rounded off, 1.02 millimeters in length to that side x.